So every time ChatGPT understands your question or Spotify recommends a music that is similar to something you actually love, there is something working in the background, and that's embeddings. Embeddings is one of the most important concepts in artificial intelligence and machine learning, but it's also one of the least explained. So today we're going to fix that. We're going to discuss what embeddings are, how it works, and why it matters in AI. So stay with me to the end, besties. Hello, welcome to Tech with Praise James. In this channel, I explain artificial intelligence and machine learning jargon through storytelling. Before embeddings, computers didn't really understand words, images, and sound. They only understood numbers. So if you tell a computer, oh, king and queen are similar, but king and bananas are not, it won't get it, except you gave it a way to represent those words as numbers to preserve their meaning. What do I mean by all this? Let's look at it this way. If I say New York, San Francisco, Miami, your brain immediately groups them to be places in the United States of America. But a computer doesn't understand it that way. It just sees it as 5 separate words. Nothing, no relevance to what the words represent. Now, this is why embeddings is a very important concept in AI. So what is embedding? An embedding is a vector, which is basically a list of numbers that represents objects. Objects here can be words, sentences, images, sound. It represents them as numbers in a multi-dimensional space. So if you did maths or physics in school, you must have heard of 2 types of quantity, scalar and vector quantity. Now, scalar is just a single number like 1, 2.5. It only has magnitude, it doesn't have direction. An example of a scalar would be speed, right? It's only telling you how fast you're going, it's not telling you in what direction you're going. An example of a vector, which is another list of numbers, you have, let me say if you have a list of numbers as 2, 5, minus 1, that's a vector. It has magnitude and it has direction. An example of a vector would be velocity. Velocity tells you how fast and in what direction you're going. So this commercial break was just to give you a visual representation of what vectors mean, and also to tell you that data science, artificial intelligence draws a lot from mathematics. So if you have a good foundation in mathematics, then you'll be able to grab what happens in the world of AI better. So make sure you strengthen your mathematical background or your mathematical knowledge to be able to flow with these conversations. So back to embeddings. Let's talk about how embeddings work. Now remember I said embeddings represents words or objects as numbers in a multi-dimensional space. Now this is where it gets more interesting. So words that have similar meaning stay close in this space, but ones that have different meanings stay far apart. So remember our first example about king and queen. Now king and queen represent man and woman in royalty. They stay in the same space because they have relevance to each other. But king and banana, except the king like eating banana, but there are 2 different words that have very far apart meaning from each other. So banana would obviously be far away from king. So that's the beauty of embedding. Now, where does embedding happen in the whole model training pipeline? For this example, I'm going to be using text embeddings. So if you're trying to convert a series of text into numbers, vectors, now this is where it happens. So let's say you're using a model like WhatVic and you feed it massive amounts of text. Now what the model tries to do is to connect sentences and relevance to other words. So this is what I mean. So if you give something like the cat is on the, then you give like dash for the model to fill it in. Now the model tries to understand where could a cat possibly be on. It could be on a bed, it could be on a mat. All these things are relevant because those are things that people stay on. So those kind of words will be in the same space because these are related words, they are relevant to each other. The model will now say, okay, based on this context, I'm thinking that the best place the cat would be is maybe on the bed. So the model will go through multiple examples. We're talking millions of texts, and then it's going to find words that are relevant to the question that you asked. So if I'm saying the cat is on the mat, it's more sensible than saying, oh, the cat is on the tap, because why would the cat be on the tap? It tries to map words with similar meaning into the same vector space and then it figures out the relationship between the words in the way that they appear together. If not for embeddings, the model will not be able to figure out what, first of all, your question means. Like when you ask it a question, you won't be able to figure out what the question means. Talk more of giving you an appropriate answer to your question. So clap for embeddings because it changed our lives. Once we have these embeddings, what can we do with them? The first thing we can do with them is semantic search. When you ask an AI system for something, you give it a prompt or a query, it converts it into embeddings, and then it finds documents with similar vectors, and that's how it's able to answer your question. So if you ask what is a noun, it converts your question into embeddings, vectors, numbers, and then it finds similar documents that are in that same vector space as your question, and that's how it's able to tell you. A noun is the name of a person, animal, place, or thing. Number 2 is retrieval augmented generation, which also applies the semantic search. I made a separate video last week on RAG, so I'm going to link it in my description so you can watch it. It will really throw more light on the importance of these embeddings that I'm speaking of. Second place is recommendation systems. Like I said in the beginning of this video, when you're listening to a particular type of music, maybe R&B, and you're listening to someone like Chris Brown, there's a reason why Spotify says, hey, since you finished listening to this song by Chris Brown, you're probably going to like this one by Friday, or you're going to like this one by Khalid. Now, what happens there is the recommender system, right? The recommender system uses data from, other users that probably listen to the same song as you to understand what kind of song you would like the most. The reason why it's able to get such similarity in song style is because of embedding. So it's converting those sounds to numbers. I want you to see embeddings as the bridge between human language and machine understanding. Without embedding, ChatGPT won't understand questions, search won't feel intuitive, recommendation systems will feel personal. But the truth is, like I always say in AI, nothing is perfect. Embedding is statistical. It's based on probability, relevance, similarity, and that means that it is more concerned with context than actual reasoning. That's why you see people say that even if AI can do everything that we can do, it lacks what we have as human beings, reasoning. It doesn't have that nuances that human conversations have. So that's where it lacks. Also, bias can creep in. Whether because you're turning something into numbers doesn't remove the bias factor. As long as the data is poised in a code, embedding or no embedding, it is still going to replicate the same, societal bias, workplace bias, whatever bias that the model inherited from anywhere, dataset, algorithm, it would still have that. Embeddings are model specific. That means that a model trained with a different architecture, data sets, and training objective will produce different other list of numbers, vectors, and that means you cannot use it interchangeably. This is not necessarily a bad thing, but it just means that to each its own. You cannot just say, oh, I don't want to build from scratch, I'm just going to lift the embeddings from here and move it to this other model. It doesn't work that way. Regardless of this, we like call it loopholes, embeddings is still, like I said earlier, a very, very important concept in machine learning. And knowing it, or even if you don't work with models, just knowing what works behind the scenes of your recommendation systems and RAG pipelines is very, very important. Embeddings are one of the forces that shapes how AI models understand the world the way that we do. So if you found my video today helpful, please like, share, and subscribe. See you next time.